Density is the ratio between mass and volume. So it doesn't matter if I have a small gold earring or if I have a brick of gold, because the mass and the volume would change from the earring to the brick of gold, the ratio is staying the same. So the density also stays the same, which means each substance has its own density no matter how much of that substance I have. So density is one way of us, or one way we can identify what the substance is. Now density is mass over volume. You might see it written as D equals M over V. And this is given to you on your test, so you don't have to memorize it. In fact, it also tells you D is density, M is mass, and V is volume. The units for mass are grams, and then volume, we typically measure in milliliters because we don't use large amounts of stuff. Or it would be grams per centimeter cubed. Now a milliliter and a centimeter cubed are equal to each other, so those two units are interchangeable. Alright, so if we look at our first problem, we have a sample of aluminum metal with a mass of 8.4 grams. So I know that this is my mass, or M. The volume of the sample is 3.1 centimeters cubed. So I know that this is my volume, centimeters cubed being a unit for volume. And it's asking me to calculate the density. So D for density is going to be my X because that's what I'm looking for. So I'm going to plug it into my formula. X equals my mass over my volume. Now when you type it into your calculator will give you a bunch of numbers, but we are lazy people, so we follow our rules on sig figs. When you multiply and divide, you use the fewest sig figs. So the mass has 2 sig figs, and the volume also has 2 sig figs. So I need to write my answer with just 2 significant figures. So we would say 2.7. The units don't cancel out because they're different, so this would be grams over centimeters cubed. In number 2, it says what is the mass of the marble if what is the mass. So I'm looking for mass. Or my M. So M is going to be X in this case. If it has a density of 2.75 grams per milliliter. So notice that both grams and milliliter are with this number. So that tells me its density. Then it says if the water level of the graduated cylinder rose from 220 milliliters to 530 milliliters. So this is where I'm going to get my volume from. Now we're not going to pick a volume, we're going to think about this. The marble was placed into a graduated cylinder and the water level rose. So what it's saying is the water in the marble had a volume of 530. The water was 220. So what's the volume of the marble? So if we subtract our two volumes, we would have 310 milliliters. So this is the volume that I want to use in my problem. So the volume was found by water displacement. So my density, 2.75 grams per milliliter, equals X over 310 milliliters. So to get X to be by itself, all we have to do is multiply density times volume gives me my mass. Now for significant figures, the density has 3 sig figs, but the volume only has 2. There's no decimal, so the 0 is not significant, so the volume is just 2 sig figs. Now our calculator gives us an answer of 852.5. But I only need 2 sig figs, so I would want to keep the first 2. But this is now 85, and it started off as 800. So I can add a 0 without a decimal to make it the same magnitude and not change the number of significant figures. Grams over milliliters times milliliters. Our milliliters will cancel out, leaving us with just grams. And since we're solving for mass, and mass is measured in grams, I know this is correct. In our last problem here, we have diamond has a density of 3.26 grams per centimeters cubed. So this is my density. Again, notice it has both mass and volume in the units. The problem says what is the volume, so I'm looking for V in this problem. So my volume is going to be my X of a diamond who has a mass of 1.14 grams. So grams is mass, so this is my M. So if I was to plug my numbers in, 3.26 grams per centimeters cubed equals 1.14 grams divided by X. Multiply both sides by X. Divide by 3.26 to get X to be by itself. Or cross multiply and solve for X. The mass has 3 sig figs in it, the density has 3 sig figs in it, so my X value needs 3 sig figs. The calculator gives us 0.3496. So the 6 rounds the 9 to a 10, which rounds the 4 to a 5. Need to put the 0 there to show that that place is significant, and it was a 9 rounding to a 10. So for the units, my grams divided by grams would cancel, leaving me with centimeters cubed. I'm looking for volume, and volume is measured in centimeters cubed or milliliters, so I know the problem is correct.